Hey team, today we're going to cover properties of rational exponents. And so, to simplify this, there are basically 6 different properties with the exponents. Let's dive into what they are. First one, let's say we had a to the m times a to the n. Well, we have the same base of a, and so whenever this happens here, we can actually just add the exponents. So this would be a to the m plus n. And so if we looked at this as an example, we'd have, let's say we had 6 to the 1/4 power times 6 to the 3/4 power. Well, we have the same base of 6, and then 1/4 plus 3/4, well, here's what it would look like. We have 1/4 plus 3/4. And however, in this example, that'd be 4/4, which would be 1, and hey, that's just going to be 6. Second property, let's check it out. We have a to the m, so we'll stick with the letter a, and all of this will be in parentheses, and all of this is to the nth power. And so whenever this is the case here, we could actually just multiply these together, and so this would be a to the m times n. As an example, we'd have 7, let's go 7 to the 1/2 power, and all of this would be raised to the 4th power. And so looking here, well, 4 times 1/2, the idea is these two would multiply. So 7 to the 1/2 times 4, well hey, 1/2 of 4 would be 2, so this would be 7 squared, and you can simplify that even further and say it's 49. Alright. Third property, let's say we had a and b together, a times b in parentheses, and all of this was to the m power right here. Well, a and b are multiplying, and all of it's to the nth power. Well, that means a is to the m power, so is b. B is also to the m power. So basically, it's almost like this power distributes to the powers here. Right now, it's just a 1 here, it's a b to the 1st power, a to the 1st power. You could write those ones in, you don't have to, it might help you. Well, that basically means we'd have a to the mth power, or 1m power, times b to the mth power. Looking at this, for an example, we'd have, let's say we'd have 4x squared, all in parentheses, and all of this is to the 1/2 power. Well, based on that property, we could distribute the 1/2 power here to both of them, and so we'd have 4 to the 1/2 power and multiplied times x, but 1/2 of 2 is 1, so that'd just be x to the 1st, and let's see, the square root of 4 is 2, or the 1/2 power, 4 to the 1/2 power is 2, so you're left with 2x as a final answer. Let's see, fourth property. So let's say we had a over b this time, and all of this was to the mth power. Well, very similar to what happened here, the m distributed to both powers, same thing, this m is going to distribute to both powers on the top, in the numerator and the denominator. So whenever this occurs, we'd have a to the mth power divided by b to the mth power again. And so looking at this as an example, let's say we had 5/64, and all of this was to the 1/3 power. And so this 1/3 would distribute to both of these numbers in the numerator and denominator. So on top we'd end up with 5 to the 3rd. Underneath we'd have 64 to the 1/3 power. And up top, 5 to the 1/3 doesn't really simplify to anything. However, 64 to the 1/3 power would end up being 4. So that'd be your final answer there. Let's see, another example. Let's say we had a to the m over a to the n. And so whenever we have the same bases, a here, we have, undo that a couple times. Well, whenever we have the same bases, they're dividing each other. That means, look up here, we multiply them, and we ended up adding exponents. Here we're dividing our bases. we're going to end up subtracting our exponents. So it'll be m minus n. Nice example of this. Let's say we had 5 to the 3/2 power over 5 to the 1/2 power. Well, the idea is we have the same base, therefore we're able to subtract the exponent. So we have 5 to the 3/2 power minus 1/2. Okay, well we have the common denominator, so we can subtract that right away. We end up with 5 to the 2 over 2, which is 5 to the 1st power, or just 5. Alright, the last property, let's scroll down a little bit. The last property is going to look like this. We have a to the negative m power. All these we had positive exponents. This one, let's have a to the negative m power. Well, whenever you have a negative exponent, usually your final answer, you don't want to have a negative exponent. So this one, the reciprocal would just be 1 over a to the positive m power, just like that. So if we look at any example, let's say we had 25 to the negative 1/2 power. Well, this would actually equal 1 over 25 to the positive half power. And let's see, the square root of 25 is 5, or the 25 to the half power would be 5. So your final answer there would be 1/5. The reason this one works is you're actually multiplying this by the number 1. So let's check it out. Let's say you had 25 to the negative half power. And if you multiply a number by 1, you're not changing it at all. That doesn't change the value of this. It doesn't change it. It's still the same number. It's still 25 to the negative half power. I'm going to change what my 1 looks like though. Instead of having this times 1, I'm going to make it my number 1 look different. I'm going to make my number 1 look like this. 25 to the half power over 25 to the half power. And this is still the number 1 because we have the exact same value on top as we do on the bottom. Numerator and denominator are the exact same. Hey, guess what? That's going to be the number 1. So I'm not changing the value here. And then we use a property we talked about previously above. So on the top we have negative 1/2 plus a positive half. And underneath we're left with just 25 to the half power. So in the numerator we have 25 to the 0 power, and anything to the 0 power would equal 1, and underneath we still have just 25 to the half power. So on top we have 1, and then 25 to the half power is 5. And so a little more work involved there, but that's what is happening in that property. And there you have it. Those are the 6 properties of rational exponents.